Vítajte na druhej prednáške z aspektu orientovaného vývoja softveru po počiatočných technických problémoch aj s projektorom ktorý sa nechcel zapnúť a aj s kamerou. Aj nahrávka, aj potom už minulé prednášky na YouTube bola nejak čudne rozsekaná do viacerých súborov. Ja som stiahol ten posledný, ako som si myslel, že to je, potom som bol na služobnej ceste. Tak trochu s oneskorením. A uvidíme, čo to spraví teraz ako s touto nahrávkou. Ale treba byť tu, tak to je najlepšie. I don't know whether we do have our Erasmus student here. Yes, great. So welcome. So then this lesson will be in English, as I promised, and all further lessons. Although we have recordings of previous lessons, and more or less the course will be the same as last year, but we always come to some different things. So I hope this is not a problem for anyone. So you're all comfortable with a lesson in English?
Yes.
Yeah. You actually may not answer otherwise, but for any additional explanations, any questions you might have, you might use Slovak, and I may use Slovak to answer some things, and then I will explain everything. You did not attend the first lecture and you did not have time to watch it because I appeared very late on YouTube, and maybe you used watched the last year's first lesson. But anyway, if you didn't haven't yet, don't worry. I will repeat some essential things that we need to proceed with the AspectJ programming language, and I will be showing code and re-explaining maybe some things that we saw, maybe in a different way a bit, because in the first lecture it was just to I don't know, to get familiar or to get familiar with the concept of aspect-oriented software development in general, not just in programming. So now we are focusing on programming, and it's the best way actually to really know, because that's the really real thing that works. So you write something, and it's compiled, and then you see the result. So it's we may imagine, and in use cases we saw how we can think in an aspect-oriented way. But when we have programming and the real executable code, it's more tangible. So the first thing is maybe to recall just a bit. I will remind you this is already this different project that I want to show you, but it continues around what we said last time. So we came to something like this. Most example. So we were working with code. I know that I forgot your name. Sorry. Thibaut, you said you're not familiar with object-oriented programming. You all are familiar, I guess, especially with Java. You don't have to be an expert in object-oriented programming. You saw something in C++, maybe you're familiar with C++, classes, some classes, no? Nothing like that. Okay, so I'll just very quick 1-2 minute introduction into this. In object-oriented programming, we program like this that we have a structure called class, but in the end you have operations there just like in C. But they're in a bundle with the data, so with attributes. So you can easily represent like a structure in C, but you add functions to it. And these functions work mainly on the data that is available in that structure. And then you have, just like the structure, instances. So when you program a point this way, you can have many instances of a point. So when you want to write something out, print out something in Java, you use this print line instruction. It doesn't matter the system out. It's like something like print. So in a sense, we are following what's happening here by adding these monitoring statements like system out, print line, set x, so that we can see that this operation, this we call it method function, we would say in C, or member function in C++, that it is being activated. And there are AspectJ constructions or constructs that enable us to follow this. But we moved one more level and another level. And this is the final thing that we had last time. We were able actually to correct the coordinates. So from our point of view, let's assume that this is so. Only coordinates for axis are between 0 and 639 are correct, and for y axis up to 399. So we are checking whether the coordinates are in this range, and if they are not in this range, we simply recalculate them as if we would apply continuous scrolling. And for this we can use modulo. So this is a mathematical thing. We are not interested in so much mathematics here, but we will touch mathematics in one more sense in this lecture. So it is important to provide a mathematical explanation there to fully understand what does it mean to capture so-called joint points. So what we are doing here is around construct is like it stops the program at this point, which is presented as or expressed as a call to set x method. And moreover, we capture the argument value. You don't need to get fully understand the syntax at the moment, but the essence is that you can express this in a formal way and non-ambiguous way. So it is completely clear what this means, what point is being captured. So when you completely specify something that is really non-ambiguous, you can make a program that does this, and this program that enables us to do this is actually the AspectJ compiler. The AspectJ compiler and the constructs and the language, AspectJ language, which is actually compiled by this compiler. This is an extension to Java which is an extremely popular language. So AspectJ drives quite a bit on this popularity. And adds these constructs that enable us to capture particular points in the program execution, and this one is a method call. So whenever this point is in the class that we had, and this set X is the method, whenever it is called, this call will execute. We don't need to put this code into this class that I displayed previously, point. So we don't need to put it there. We don't need to put it directly. So these are not actually calls; these are executions. Like when we could capture even directly executions. So without being limited by where the calls are placed, but most often we want to put this or work with this dynamically. So we need to capture certain calls in certain classes or certain other methods and so on. We will see how to do this shortly. What I wanted to show now is that these are the calls. So this is the Java way to express the main method where the program starts. You can have many program entrance points like this. Unlike in C, you may have only one main method. But here you can have main methods in many classes, but this is not important because here we have only one, and it must be put in a class. So it doesn't matter whether it is it doesn't matter what class it is, more or less, because it is declared static, and this is actually the way to say that we are falling to the procedural level of programming or style of programming, just like so easily this could be put out of the class. But Java requires all methods to be placed in classes. Nevertheless, the behavior is exactly like in the C language. So we have calls. We establish this is a way to construct a new object, and we call simply these methods on this object, which means in the context of the object. So the variables. The attributes that are present in the point class are actually replicated when we make an instance, and each point has its own x and y coordinates. So we actually would create several points, then we would have replicated these coordinates and they're set in their own way, so they preserve value. So here we have only one point, and we play with setting it in different ways. So this is 900, clearly not within the range. So when we start this program, so the output that we get, so this is simply to get the values, is not 900 but 260, so it's recalculated based on our algorithm, which is visible here. So this is what we actually achieved the last time, and now I mentioned the notion of join point. So the point in the program execution where we join with our aspect, so additional functionality, and we actually can, in a way to say, swallow this join point. We may prevent it from being executed by not using this or applying this to proceed. here proceed construct clause. So if you don't apply proceed within this around construct, which we say called advice. So this is a piece of advice. Advice like not really a recommendation in this sense, but another view. Just a different way to say aspect, because we use this aspect notion is used to denote a whole container which may contain several pieces of advice. And here, if we do not use proceed, nothing will happen. So we need to put in this kind of advice. There are two other different kinds of advice you can imagine or recall. So we have this one that has full control over the join point. This is the most complex one. But we might want to put something in front before the method is being executed and after. So before and after, or we can hold the method execution, or call in this case to be precise, and decide whether it will be executed or not, whether we let go or not. And we can even change or adjust or complete or provide completely different arguments. Everything is in our hands. It's like just as if you could stop the reality for a moment and say, okay, so I will rearrange things here, and then reality go on. Yes?
What would happen if the function was supposed to return some value, like an integer, and we didn't provide proceed? Will it crash?
So if the method, the set x method would
supposed to return some value except void.
If you declare it like this, so for example, we put it to otherwise. So if you would say here int, so this is a different, but easier for me to change code because I don't have to put the return construct. So if you put it this way, this will simply not correspond to the method that we are capturing. So because it says it's void. So if we execute this code, it will simply not capture this.
Yes, but if we also change our capture so it matched, and we didn't proceed, would it crash? Like if we didn't run at all?
So if we did not, if we do not use proceed.
Yes, so like if we return it
like this. Like this.
Yes, but the function is supposed to like return something. For example, we want the integer a and it didn't run. Like is it
this way,
return now?
Yeah, this way it won't be simply it won't be executed. This call like it will not be like that it starts executing and then the value is missing. It simply won't be executed. So if we try this like so this is one thing and another thing, or we have such a method. So we could do this in a different way. So I could use reuse this code in a primitive way to capture this set not set, but get x, and actually we do not capture arguments here, any arguments, we don't need this because, or actually, no, it doesn't have any arguments, so consequently we don't need this, and we want to say that we are not proceeding in any way, so there is no code there. So do we have a get call here? Yes, here. So when we start this code, so we have this 260, but this is this code is not being captured, and because I made some mistake, there is no mark, this small mark here, so I think
it has different return value.
Yeah, different, yes, you're right. So it may need to be honest. Okay. And now this is actually the problem. This is not being applied, but I don't think this is. This should be an error. Let's see. Try to use maybe the better. This is not the file. So
I think you have to replace void around it.
Yeah, this is a problem because yeah, around you're right. I forgot this, and this is another point that we need. Around needs to follow what's being captured. So if you change it to void, then it means that the captured place would be void. So here, I guess the problem is that we would be forced. Yeah, we would be forced because the point is actually captured, but when you release it, you should remain with some return value. So I guess this is the case that I don't know the other way. We cannot use return because there is no such thing here. So we would need to return something, and this should be more or less correct.
Return proceed.
Many, no, it doesn't have proceed.
I think you have to use return proceed. Return proceed.
Return proceed. I don't know. I don't think that we can use here exactly. Maybe. Let's try. So I'm confused now. Let's try this. Yes, you're right. Yeah, we can use return because this is considered to be we are returning this value, but once we have return value here, return type value here, so we can return. So we don't have to return proceed. We can return whatever we want, but we need to return something. So you're right, because it would be so. This is one thing that I did not think of previously for this. Discovery. This is something that has to do with consistency. So AspectJ follows strictly what Java represents, and it may not spoil anything there. So the constructs that are being invented in AspectJ have to be consistent with Java behavior. So here we would simply say that nothing happens. Still, Java expects some value here. So we need to it somehow, and this is one of the ways that we can do. So probably, yeah, no, it's correct. So if you execute this, you get 0 or whatever value that we put there. Usually, we do not want to do anything like this. Usually, we do some changes, as I showed here, some adjustments to arguments and some things, and then let the method, the original method, calculate things. But there are strange situations that I will demonstrate you in the next lesson, when we can even provide a completely different kind of an object in a place where some other kind is expected, or some things like that. So I think we might at this moment discuss what kind of joint points you would imagine would be useful to capture. So joint point, as you saw, is a point captured in program execution. In a way, we do not work directly with these joint points, but with joint point shadows, so-called, which are corresponding programming language constructs, because we do not work directly with the program during its execution. We prepare everything and then start execution. So the question for you is now, if you would be proposing an aspect-oriented language, capturing of what kinds of joint points would it enable? Certainly there is call, but I would like you to think for a moment about this and possibly discuss this with your neighbor, and then we will discuss the possibilities. So one thing is, you don't need to guess what kind of joint points AspectJ captures, but what would you think, find suitable to capture? While you're discussing this, some of you already might suggest some kinds of joint points.
Try catch.
Try catch. So in C you don't really have this, but these are exceptions, so-called exceptions, where you put some code in a try construct, and is being safely executed. So if it fails, it doesn't mean that the whole program will fail, but then you have the exceptional situations that you capture, and you have a range of catch constructs that resolve these situations. So if you manage to somehow fix the situation, you can continue with the program, or at least you can provide a user-friendly message to the user that they won't be happy anyway, but the program crashed. What was the problem, at least? Some communication. We had this, yeah, I don't put it because we know that the call, actually, maybe to be more precise, what we work with, method calls, some other things that might be useful to capture. We're talking about Java, but
Properties, like get and setter methods.
get set methods, properties. This is a new construct. I don't know how it is. Properties. This is a.
It's from C#.
From C#, but I think Java added some things along these lines, not elaborate successfully. Forgot. I'm not sure how. Now that I'm thinking of this, how AspectJ follows these completely new constructs. The modularization does not really affect aspects that much. Maybe when you qualify the names, maybe you need to use modules or some things. I'm not sure how it is resolved, but for this kind of basic Java constructs that we know for some years, because Java extensively developed during its lifetime. It was quite a simple language in the beginning, but we all know that there are some constructs for certain. So this is certainly applicable in C# as you mentioned. But let's return to Java. What other constructs there are that you might be that you might want to capture? Method calls are one thing, but as I mentioned, some situations it's really execution that you want to capture. So whenever the method is executed as such, if it's a call, it may be placed in some given capture, you may restrict which calls are captured. Method also methods we might consider constructors to be methods, but we might treat them separately. Okay, so we consider also constructors to be there. So this. So constructors to method calls or executions. As I said, we are not going to elaborate this, but think of all kinds of initialization that Java has. Might be not used that much. So initialization. What other things are there? Classes besides methods.
Could it be used in like cycles, like for while?
This is another thing. So loops. or even maybe if expressions, for example, or such things. In some situations you might like to capture these, but something that you use very much is inevitable, are attributes. Setting, getting the values. So attributes. So attribute values. What other things you might imagine there? Yeah, I have some list. AspectJ. The attributes are called actually fields in Java commands. So field access, reading and writing, as I did here. Methods and constructors, call and execution. Exception handling, so it's there. Initialization on all levels. And one more thing that we missed is advice execution. So once you add a piece of advice to some point, it becomes a part of the program, and you can capture it as well. It's just an additional join point. So what is not there are loops, if expressions, and maybe some what else could be there. They are not there. Do you imagine specifying a loop? You would need to invent a construct like this. So we work with something primitive or elementary point cuts like this. This is one of them, and another one is here. These arcs. You would need to invent a special point cut for this. But the methods have their name. Constructors are placed in classes that have their name. The problem with loops or if expressions is that they have no name. You can label them somehow, but you do not do this normally. So maybe some annotations, maybe or something like that, depending on the language. But you do not do this normally. And there could be several similar while loops or for loops in your method. You could easily get or specify, okay, I want to capture a for loop in this method, which is called, I don't know how. You could say, you could easily specify that I want to capture the first or all or something like that, the second one. But the problem is that, and you can easily specify also, I want to capture a for loop where the range of the iteration is like this or something like that, whatever. So there could be some properties of the loops that you would follow, and by this you would capture the specific or a specific loop. But as you can imagine, as I was explaining this, I did not manage or haven't managed yet to specify all the possibilities, and you could imagine that your loop would easily travel around the method removed or preceded by some other loops suddenly, and this would break the point cut. So this is one of the features of cards that we want them to be robust, to survive the changes in the main program or the program that they affect, and we do not want them to be fragile. So fragile means that something is breakable, and these kinds of point cards would be very fragile. So this is why they decided not to include, probably not to include these things, and we work in AspectJ, we work on the level of methods. We do not go directly. We go inside because we have their field access, same truth, but we are not working with particular control constructs within methods of constructions. So, but when you think of these, is this the only way? These are constructs, literally constructs within a programming language. Is this the only way to think of a program, or would this be sufficient to capture all you need? We already saw some indication that I wouldn't answer anyway, otherwise it wouldn't be the case. But its arguments point cut. What does it do? Arguments. It captures an the argument value. Yeah. So, but it actually, if you would have like this, without call, what does it mean? Means what it says: capture all the joint points where the argument is of integer type and capture the value. So we could do this also in a different way, like this. We won't this won't be correct completely because now we won't have x here anymore. So you don't want the value, you just want to capture all the joint points where the arguments are that have one argument and it is of integer type. So like this, we capture the value as well. We could say this is only related to method calls or constructor calls or executions, but it has an extended meaning. So it's by convention. It's not given by any logic or logical explanation. Well, logical explanation is that it's similar, but it also captures all the places where there is integer attributes are set. So whenever there is because it's like an argument. When you're setting an attribute, the attribute value, you're providing some argument that is being used to set the value of this attribute. So it would capture all the places like this, and maybe I don't think but we have some number of places like this. So let's play this in a different way that I did not do so far, but it should offer you a glimpse of what is actually going on. So you will just put a message like this. So we are capturing something wrong. So it shouldn't be. We are capturing. Well, when it's a problem with the value time, we should get around objects or something like this. Not sure if that. Let's simplify this a bit, and let's say that this is before, because around is specific, because it actually we don't want to prevent anything from executing. We just want to show that something is being captured. So let's relax this, and let's see what is happening. The problem is that we are having this on top. So let's. I will need to add something here that I must explain later. So we need to. We are actually because we are capturing this. We are actually our piece of advice is also working with an attribute, so it's being captured by itself. So the thing is that we need to say that we do not want any joint points captured within this aspect. So this should resolve this situation. And I will explain this briefly in a minute. So we are capturing many things here because there are several places when we set x, set y, and so on. So within point class, we actually work with attributes. So whenever these things happen, whatever integer attribute is being dealt with is being captured by this aspect. And actually, this piece of advice does also, as I mentioned, work with arguments, with attributes. So we here say that we do not want this being captured. I will return to this first. Let's talk a little bit about this idea of capturing all the joint points that have an argument of a particular type. Yes?
Is it possible for multiple aspects to affect the same point cut?
Yes.
And what will happen if the other case, like, will be all in the competition? Like,
yeah, there are some rules according to which they will be applied, which are actually conventional thing. I have this maybe in this lecture or the next lecture, because this is a bit of an advanced thing, and usually you don't want to mix too many aspects, so you play really carefully with this. So that there are rules, but because you have different kinds of advice before and after, and it's something like that with executive first, but then like has a priority, and then after, then around. I'm not sure, but it depends on the order also of how the pieces of advice are placed within the aspect. So it's not that they had made some convention. So it's not something that you want to use or rely on very much, because then you would add some other aspects, and things would be go crazy. And there was even an approach to put aspects in layers. It's called aspect stratification to resolve this. This was considered a real problem. But in AspectJ it remained like this, so it was an experimental extension, or even maybe extension to AspectJ or something like this that some researchers played with some years ago. So let's think about this. So this is not clearly arguments. It's not that kind of point cut type that we had here, simple things. It's a more complex but conceptual thing. So we think of a program and we think of the possibility to capture all the places that have some specific type of argument. This way, we actually specify joint points that need to be captured in a different way. It's in a different way. It's not that simple that we just follow these constructs. And we forgot here one more thing that is not present in AspectJ, local variables are also not being present in AspectJ, so you cannot deal with local variables. They are also not very stable. So we work with joint points in a bit different way. We saw this argument point cuts just now, but there are several other things. Like some of them follow this simple idea of a particular kind of a joint point, like method and constructor calls and distributions. Field access, but control flow based point cuts. These are not something that you don't see this as a language construct, but you know what that you have control flow. You have a method, and then in the method you have calls to other methods, and then calls from these methods you have calls to other methods. So when you draw it as a sequence diagram like this. So first you start with some methods. I realize that this is not being actually recorded, but what can we do now? Experiment with camera placement some way. So we have this, and from here, maybe I will draw this activation block, or actually execution specification. So this is some object. This is a call to some method, and then we have many other objects. I will not draw these execution specification blocks anymore, but the arrow should be close, head, So it's a synchronous call. So this is a kind of a F, and maybe then even G. But within G, we might have further call here to some W, and this is, I don't know, an object of a class A. This is a B, and this is C, we might imagine that we want to capture everything that is happening within this method. So all this. Clearly, it's a concept. I actually circled it, so you can see it. We can talk about it. But it is not a language construct. So, if you would capture, you would say you want to capture control flow. So control flow, or show C flow. C flow, but what? Of this method call. So eventually you would need to put there this call point cut, where you would specify this. Whatever it is, whatever it returns, it doesn't matter. So I can use these wildcards. It's a method which is actually class A method, as you can see. So we can specify this, and we have this control flow construct, and this is just what is mentioned here. Control flow based pointers. We have several other things. I'm not going to go through them at this moment, but we will see several of them in action in the example that I will be showing you. But this concept is very interesting, because when you say, give me all the joint points, whatever kind of joint points are there, give me all the joint points that are here within this control flow. There might be the sequence diagram does not really show. You can put it there somehow, but normally you don't put there how you work with attributes. So setting, getting attributes. So whatever, or whether there will be some try-catch box or something, whatever happens here within this control flow, give me back those joint points, and I will do something at these joint points. Typically, you don't want. So this is a set of joint points. Can you see this? This is a set of joint points. So point cuts specify sets of joint points. Sets of joint points. It's not, even if it's one joint point, it's an element of a set. So you always get a set of joint points. If nothing is captured, then it's an empty set, but still it is a set. So we work with sets of joint points, not with individual joint points. That's how you specify things. So give me this whole set, and I can say, okay, but within this whole set, somewhere there, I want to capture this method call W, which is a method of the C class. So if I want to do this, so I have this set. This set will be a set of how to mark it. Let's say that this is set S1. So the whole set, this is set 1, and this joint point is not really one joint point, but you must work with a set of joint points. This will be set 2. So this call might be placed somewhere else as well, but I want it just within this set of joint points which represents the control flow of method M. How can I, in mathematical sense, specify this? If we have this set and this set, S2, which is not actually just this set, because I cannot really draw this here, because I would need to draw further sequence diagrams and so on. But you can imagine that outside of this, and I will indicate this like this. So there is a small part. So let's close this here. So this is one set like this, and we have another set, and it is being a piece of this set. So here we might have further calls to this method, which are not within this. So eventually, if I redraw this here, we have two sets like this. So S1 and S2, and what we need to capture here, this call to W, is here. So what is the mathematical concept in the set theory that gives you this? Intersection, exactly. So let me just see whether we can record a little bit of what I draw here. Not very visible, I guess. So intersection. So it would be S1 intersection S2 like this. But we are not operating. We do not have exactly these sets like named sets. Like we do not have the elements directly put or provided one by one. We operate with set specifications like control flow. So one is specified as control flow. So all the joint points that are in this control flow. There is a mathematical expression that can be used to specify this, but let's not bother with this. But we know that when we have these expressions, in its way, logical expressions that specify something, we cannot conjoin them with the set operators. We can conjoin them with logical operators. And we have these operators, most notably, like we can have set intersection, and we can have some other sets, S3 and S4. We can apply union to them, so unify them. And in mathematical logic, you have operators or, which are written like this. So and or. And you can see how these operators resemble each other. This one is all, but it looks like and. So when you have intersection and when you say these are actually some conditions that must be fulfilled, like control flow, and with this expression that we have plus it must be a call. I will make this shorter to W. So it is the AND operator that we have to use. And we are not here in mathematics. I don't know whether actually write this so that you cannot really see this. Is it visible at all? You should be sitting here. So this is an operator in a mathematical way, but we are in programming, so we do not put it this way, but we use ampersand and sometimes like this. And for OR operator, we use two lines like this. Pipes. So the thing is that we work, and we will look at further examples like this, that we work with some operators. So let's have a look at some further examples. You will play with them but let's see how they might look like. This is something different. So you will activate these examples in the exercise, but let me just briefly show you that you can put it this way. So this is a really straightforward way to specify one kind of joint point, and most notably it would capture only these set X calls, but you can extend this easily using wildcards, as I demonstrated a bit in what I was writing here. So you can use wildcards. So we will experiment with this. Almost anything you can imagine can be treated with wildcards. So it can help if you have methods with similar names, which is the case when you actually name the methods, the names should be semantically correct. So you do not use normally name methods like A, B, C, and so on. Like in mathematics, we tend to name our concepts like this, but in programming, we use more understandable, comprehensible names for the concept that we use. So it's only logical that they are related, and you want to capture them together. So you can use these things. So let's not worry about this. But what you would be doing here, and if experimenting with this code during the labs, is that you would be using this construct in order to see what kind of joint points we captured. Maybe I would just briefly demonstrate how it goes. So first of all, before I get to this control flow example, that is actually all together with this example. So here we have this point monitor like this, but it is being excluded from the compilation. So you know that when you exclude an aspect from the compilation, it will not affect code, and it's the way to turn it off. So just put it out. So I should put it back to build path. I never know exactly which one of these is. But I had to build path. No, not really. Not good. It's just became a reference library like this, so build path. And let's put it like this. This really thing that it has to do with Eclipse. This is another aspect that I don't want to bother with at the moment, so I will need to this normal view. So here got about so I won't use the whiteboard anymore, so let's focus on code examples. So let's just demonstrate how this joint point construct that displays in a nice way the joint point that you're capturing, the timing of the joint point that you're capturing. So I have this like comment, and I can activate whatever I need like this. It doesn't look maybe too nice, but it's flexible because you can easily compare the lines of code and experiment with them. So I will show you the example. The example here is a little bit different, and there are shapes. There is a point, and there is a shape. Which is actually a list of points. A list of points that forms a shape. Like you have discrete points, and they will be connected by some lines, but it's just a simple abstraction or what we might really need in a graphical program. So for the order how in which these points are connected, we can imagine is follows their order in this list. So don't worry about if you don't recall this constructor from Java called list. It's just, as I said, a list of values, and there's a specific kind of list called array list, but it doesn't for the purposes that we use this construct here. It's just a sequence, a list of points, and it represents a shape. And when we construct a shape, we simply provide these points like this. So these are 3 points, so this is a triangle. And then we can work with this shape, move it and so on. But it really doesn't matter for this first that I wanted to show you, which is capturing simply what we captured so far, but it will display the name of the joint point, or the kind of joint point. So this is not an executable part of the program, but this should be. So we have here before call, we have this is our program report, and then we have before call point set x again and so on. So whenever, and I did not provide this report. So this is provided solely by this construct, this joint point. You know that this, what do we call it, clause or variable, which is actually, it provides the reference, it's actually the reference to the object being executed. If you provide, like, you know it from Java, so let's put it like this. So that would be an object. I guess I can use this as well, like this maybe. Won't be too nice, so let's put some space there. So in simple Java, it would be just a reference to the object. But AspectJ for this joint point, so this is your reference. Not very useful to understand what's happening. But AspectJ is programmed or constructed in such a way that this joint point provides you the type and some data related to what kind of types it's related to for the joint point. So you can really see what's happening. And as I added this reference, you might imagine that, and you can see that this is a reference to the aspect object. It's a paradox, maybe, to say that aspects are also objects, but they can't be anything else. So your point monitor here, which is an advanced way to monitor what's happening, I created a separate class, a separate aspect for this to monitor what's happening, is actually instantiated and only one instance is being presented there. We will see how this can be done with several instances in the next lecture, but for the time being your aspects are made sufficient to have only one instance, and this one instance follows all the things that are needed, which are captured by these pieces of advice. So let's get rid of this, and let me show you just one more thing, and or two more things. One thing is here, and the other one is just a ball. So let's just see these arguments. Joint point. Point cut. So let me save this first and execute. So it's much richer. So we can see what kind of joint points are being captured. So these kinds of joint points are actually represented as actual AspectJ built-in elementary or primitive point cuts. So the set point cut is the one that enables you to capture when you want to focus just on setting attributes or fields in Java parlance. So you use it. So we see here that first x is being set, then y is being set, then there is a call to set x, then there is execution. So these are two different things. Then again set and so on. And we can even see that it captures some things even within Java API, because this is the thing how we construct the output when we prepare it to print it out, because we have this print line calls and so on. So how the output is being constructed. So even this is being captured. So you see that this simple point cut here captures a whole set of joint points, and these joint points, moreover, are not of the same kind. Yet another thing to consider is this. So this is something similar to what we had with control flow, but it is lexical. So I want to capture all the joint points that occur in a particular class. In this case, this is the point class. So this class has its methods, attributes, so several things are going on here. So we can imagine that we will get also a rich output. So let me execute this. So we see that many things are going on here, including initialization, because there are constructors and there is a static in the part, that pre-initialization and the initialization itself, which is actually when the constructor is being called and then executed. So this is an interesting thing, and you can work with and play with these different kinds of initialization as well. You can focus on particular parts of initialization. Normally we do not bother with this, because this is probably not too much needed when we work in our endeavors. When we want to capture some things, we usually do not work extensively with initialization, but it can be done. So also we have here the control flow, point cut, and so on. But let me just remind you of this example that I had, that I used here, not within. So I said that I do not want joint points that are within my aspect. You will play with these examples, and there are explanations. So with control flow and with this example, you will see again why this construct is important. So you want to get rid of the joint points that are generated by your aspect, and they are generated recursively, because once it captures the joint point that it is designated to capture, it generates another one, and then it captures this one, and so on, and you get stack overflow. You have your stack call stack simply cannot handle this. The calls that are put on this stack, there are too many calls, and the program will break. So this is not the only thing that I wanted to show you with control flow. Let me just, in the remaining time, demonstrate a little bit, and you can play actually with this during the lab. Demonstrate how it can be used and why it's important. So let's get rid again of this point monitor. Although I actually commented all the things there, so it's not active anymore. So I will just exclude it from the build path. You can't really see it because it's too little. But that is exactly what I showed you before I started explaining this example. And I will include the range control. So point monitor is not interesting anymore. So let's see. So point, shape, I actually explained shape, but I didn't say anything about this move method. So when you have a shape, let's imagine that in our program, the shape can be moved, relocated to some other place. Where it is relocated is represented by yet another point, because we need a set of two coordinates, a pair of coordinates, x and y. So the distance by the x-axis and y-axis that we add to the coordinates of each point in our shape. It's a simple thing. This happens in our shape class. And I have this range control like we had it before. So this is the same calculation that we had before. Because we are still working within this limited resolution, and we want our shape to be simply scrolled to the right location. And what we do is what we've done before. Okay? So nothing special. So we can just capture all calls to the set x method. But the thing is that we have here also some access or settings of these x and y coordinates outside the shape class or outside any particular shape. We have some free points. Imagine that we do not want to capture them. We do not want to affect them. But this construct that we have here is not limited. So it will just recalculate any coordinate. So if we execute this, I hope that I have all the I have this I'm printing out the coordinates of this separate point, and I'm printing the coordinates of the shape points. So we see that everything is being recalculated, but we do not want this. So one way to exclude this, because we remember that we are looking at sets, is like this. So I'm using the section. The line is broken here, but this is is actually the continuation of this expression. So we capture all the calls, again, setX method. We capture all the methods, this is an intersection again, that have this integer argument, and we capture this particular value of this argument, but we want to limit this to be within the shape. Will this work? It should, because we limit everything to be within the shape. So let's try this. I'm not engaging this part here, so I will do this for the y coordinate is just the same thing. So you see that this free point remained untouched. Because we said we want, this is another class, this is example class, and we limit the effect of our aspects or our advice to the shape class. However, if we do change our program a little bit, and we introduce here something like this. So something like this. We introduce an indirect moving. So like there is one method. There is one more method that actually one method moves a point, and another method moves the whole shape. We are still within the same class. This will work again. So I will not demonstrate this, or I can demonstrate this second, and take 2 minutes of 4 minutes of your time to end this example. So here we have the situation that we introduced one level of interaction, but it's still within the same class. The within point count works fine. But consider this. So here we actually introduce another class which is called point mover. It's completely useless, of course, it just complicates the situation. But you might add this because of some kind of additional flexibility, because it's used in some other context and you want to program it in one place. So you introduce one class. You have your aspect like this. So your aspect is, as previously, the range control that you have here. So here with this within, you have it like this. Your advice, pieces of advice. So if you have it like this, and you introduce changes to the program part that is being affected in this way, you will see that it doesn't work quite anymore. So you actually, wait a minute, just a minute. So actually these coordinates are not being, the problem is that nothing is being affected anymore. So we do not like these are fine, but 1300 are not within. So what happened is that we are outside of the shape class. We are in the point mover class where we change things. So it's not within the lexical scope of that class. So the within point cut fails to manage this, and we must use what I showed you and explained here extensively, the control flow point cut. So it's like this for the y coordinate, and let's have a look at it here. So control flow intersected with call to set y, and we can do the arguments. But it is a control flow of the move method. When we take a look at the move method here, we see that we will eventually even get this point mover, because it really doesn't matter. It's a dynamic thing. You will capture everything that's happening here. And when we execute this is the last thing. It behaves correctly. So it behaves correctly, so we capture everything that we need. These examples are available on Google Drive, so you have the link, and Tomasz will direct you to these examples. So you can play with these examples during the exercise. And I will stop with the lecture here. We have several further things that we might discuss during the next lecture, but don't worry that we did not cover all the aspects of the AspectJ. The next lecture will be also devoted to design patterns. So more advanced constructs, more advanced things, how to deal with more advanced situations in AspectJ. Any particular questions at the moment? Okay, thank you for attending, and please do install Eclipse, do play with AspectJ, and do it during the lab time. Do it at home as well, but during the lab time you can always ask Jakub, I said maybe Tomasz, Jakub for the explanation of what's happening, why do I get this error, why this doesn't work, and so on. So use this time wisely and try out these things.